Hello, in this video tutorial, we're going to be looking at skills practice 22.1, light intensity. Please remember to pause or rewind the video as you need. Let's begin. Light is a form of energy. Light intensity describes the amount of energy per second falling on a surface, using the units watts per meter squared, where watt is the unit of power or energy per second. Light intensity follows what is called an inverse square law. This means that the intensity decreases with the square of the distance from the source. Okay, so if you double the distance from the source, the intensity is 1/4 of its original value. If you triple the distance, the intensity is 1/9 its original value. Most light sources distribute their light equally in all directions, producing spherical patterns. That means the light is sent out everywhere in a spherical ball. The area of a sphere, the surface area of a sphere, is 4 pi r squared, where r is the radius or the distance from the light source. For a light source, the intensity is the power per area. The light intensity equation is as follows. I, which stands for intensity, is equal to power divided by surface area. Remember, the surface area is this part right here, which is 4 pi r squared. Okay. Remember that the power in this equation is the amount of light emitted by the light source. So when you think of a 100-watt light bulb, the number of watts represents the energy for each second, or the power, not how much light it emits. Most of the energy in an incandescent light bulb is emitted as heat, not light. That's why they're very hot, but not as bright. A 100-watt light bulb will emit less than 1 watt of energy, with the rest being lost to heat. Let's take a look at the example question, which is number 1. For a light source that is 60 watts, remember to annotate the video, to annotate the question. We're going 60 watts is power. Okay, what is the light intensity 1 meter away? Well, 1 meter would be the radius, okay, away from it. And we're plugging in, you can see we're plugging in 60 watts for power, and we're plugging in 1 meter for radius. Okay, so now just to clarify how this calculation worked, first, before you actually calculate anything, go 1 squared, which is 1, times 4 times pi. And when you do that, 1 squared times 4 times, everybody has a pi button on their calculator. You just have to look for it. You might have to go second function or shift to get it, but everybody has a pi button. Okay, and when you calculate this, we actually end up with 60 watts divided by 12.56. Now, when you go 60 divided by 12.56, that's where you get 4.77 or 4.8 watts per meter. So the unit for intensity means brightness. The unit for intensity is watts per meter squared. Okay, so let's go through these questions together. Remember to pause or rewind the video as you need to. I would challenge you to pause the video and actually try and work the questions independently and check the video for solutions to see if you're correct. Number 2. For a light source of 60 watts, watts is power. What is the intensity 10 meters away? That is our new radius. So we're looking for intensity. That's our question mark. We are given 60 watts of power. We are given a radius of 10 meters away. The equation we're looking for is I is equal to power over 4 pi r squared. okay? Power over area. Plug into that equation. 60 watts goes on top. 4 pi times 10 meters squared goes on the bottom. Now, to complete this calculation, it would be best if you calculate the bottom part first. Okay, what I mean by that is start with 10 squared, then multiply it times pi, then multiply it times 4. Okay, take care of the bottom part first. 10 squared is 100, and then multiply 100 times 4 pi. Okay, now if we multiply 100, which is 10 squared times 4 pi, you get 1256.637. Now divide 60 by 1256.637. Okay, and we're going to get an intensity of 0.048 watts per meter squared. Now that answer makes sense because if we are only 1 meter away from, let's say, a light bulb, it's very bright in our eyes. But if we're 10 meters away, if we're 10 times farther, that light bulb is going to appear very dim. Okay, so this is very dim light that we're looking at. Number 3, for a light source of 60 watts, what is the intensity of a light 20 meters away? So now we're going twice as far. We should expect our answer to be even less because we're farther away. Here's our radius. We've got our intensity. We are given a power of a 60 watt source. We'll just call it a 60 watt light bulb. The radius is now 20 meters away. The intensity equation would be power divided by 4 pi r squared. Substitute into that equation. 60 watts divided by 4 times pi times 20 meters squared. When you do this part, do your 20 squared first, which is 400. Then multiply 400 times 4 pi. And you'll get 60 watts divided by 5,026.548. Okay, divide those two, and we're getting a very small intensity, 0.012 watts per square meter. So our intensity has gone down, right? Even from the last example. Number 4, if the distance from a light source doubles, how does its intensity change? Okay, so we're looking for intensity. We are told that the distance r doubles, which means, right, is equal to 2. Okay, the relationship, we're going to do a different relationship this time. We're going to go 1, we're going to use a proportionality, not the actual equation. The actual equation is power divided by 4.4 pi r squared. The proportion that we can use is that I is proportional to 1 over r squared. And that's what we're actually going to be dealing with here. I is proportional to 1 over r squared. Let's use our proportion. Well, what are we going to put in place of r? Well, our distance doubled. So it's 1 over 2 squared, or 1/4. So in other words, how does the light intensity change? The intensity will be 1/4 as bright, or 4 times dimmer, if you want to think about it that way. And finally, number 5. Answer all the following problems from a distance 4 meters away. So R will remain constant. What we're going to change in each part of this is the power. The power starts off as a 1 watt light bulb, then 10 watts, then 100 watts, then 1,000 watts. So in each case, you're looking for intensity. Intensity is what we're looking for part A, B, C, and D. Okay, we are given R is 4 meters away. Okay, for part A, you are given a power of 1 watt. For part B, you're given a power of 10 watts. For part C, you're given a power of 100 watts. And part D, you're given a power of 1,000 watts. Okay, so here's what we're going to do. We're going to use our power equation. Okay, so power is equal to, light intensity is equal to power divided by surface area, which is 4 pi times the radius squared. Let's take our solution box and divide it into 4 pieces. So we have room for part A, B, C, and D. Part A, we're going to go intensity equals, now we're going to go 1 watt over 4 times pi times the radius, which is 4 squared. Okay. Now, the denominator is going to be the same all the time, which is going to make the other calculations very simple. The denominator, we're going to go 4 squared, which is 16, and then multiply 16 times 4 pi. Okay, and so we're going to get 1 watt divided by 201.06 square meters. So divide those, and we get an intensity for a 1 watt light bulb of 0.00497. Okay, watts per square meter. Very low intensity. That makes sense. A 1 watt light bulb is not very bright. Okay, therefore it's going to be very, very low intensity calculation. Now, notice the bottom number here that we have here is going to be the same 4 pi r squared for every one because the radius is the same all the time. All we have to do is change the numerator to fit all of the different powers that we're going to do here. So let's do this together. Okay, so for the next one, we've got our intensity is now 10 watts divided by 4 pi times the radius squared, which would be 10 watts divided by 201.06. What do we have here? 10 divided by 201.06 is now 0.0497 watts per square meter. If you look, the difference between part A and part B is that part B is only 1 0 in the decimal point instead of 2. Part B is 10 times larger. Well, that makes sense. We have 10 times as much wattage, 10 times the power. Therefore, we have 10 times the intensity. So part C, if you think about it, we're going 10 times greater with a 100 watt light bulb. So I would equal 100 watts over 201.06 meters squared. And what do you know? We get 0.497 watts per square meter. You can see that this answer is just 10 times larger than this answer because 100 watts is 10 times larger than 10 watts. Okay, and then finally, part D, our light intensity is going to be 1,000 watts divided by our 4 pi r squared, which is 201.06 in this example, square meters. And if you're following the model here, every single answer for B, C, and D is 10 times larger than the original. So our answer should end up being 4.97. If we put that in the calculator, 1,000 divided by 201.06, sure enough, we get 4.97 watts per square meter.